Hi, we're Team 2 and our project is Reading Star. Our client for this project is the National Autistic Society and Intel. Reading Star is a karaoke app for neurodivergent children with speech and reading challenges. Many neurodivergent children face difficulties with verbal communication, which can affect confidence and learning. To address this, Reading Star uses a karaoke style format where children sing along to familiar songs, and the goal is to make speech practice fun and engaging, helping children improve word recognition, fluency, and comprehension in a stress free way. Functionally, it is required that the system will perform real-time offline voice-to-lyric matching, allowing children to sing along as the app listens and highlights lyrics accurately. It will support YouTube link transcription so teachers can easily select and use custom songs. And non-functionally, Reading Star will be a Windows native application and the system must be responsive in real time and feature a straightforward, accessible user interface designed with inclusive principles in mind, providing ease of use for both children and educators.
The system has three main components: the front end, the back end, and the storage. The front end runs the back end through API calls, which has access to the storage where the OpenVINO models are kept, as well as the playlist. The back end serves API endpoints where the Whisper model, the semantics model, the YouTube API, and the playlist methods can be accessed and manipulated. Through post requests and get requests, the front end can send the audio recording to the back end, where it goes through the Whisper model to get transcribed. Once it's transcribed, it can be compared to the lyrics that's gotten through the YouTube API using the semantics model. And the front end can also invoke the playlist submethods to create new playlists, add new songs, or pick one out of the existing playlists that are curated.
Reading Star has many brilliant features available to make this the best speech practice experience. First, it displays lyrics, and then whilst you sing along to the song, it offers real-time lyric transcription and speech feedback, powered by the OpenAI Whisper model and optimized by the Intel OpenVINO pipeline. It also rewards correct pronunciations of in-game stars and points. Even while singing, you can adjust the scoring difficulty to be more strict or lenient with rating your pronunciation and giving out rewards. Finally, when you finish the song, Reading Star takes your recording and calculates a final accuracy score for your performance to provide more detailed feedback, once again with Whisper and OpenVINO. You have plenty of choice in a song, with an integrated YouTube player and the ability to save your songs in playlists which you can create, delete, add, or remove songs from. Meanwhile, once you've selected a song, focus mode removes all distractions except the lyrics and score and allows you to lock in completely on the pronunciation. While in focus mode, you may also wish to select a background to further augment the experience. And if you don't want to be scored, at any point, you can just turn off scoring mode with the switch on the top of the screen. Finally, Reading Star has plenty of accessibility settings, such as changing the background color, font color, size, type, and more to allow for a completely customizable app and experience.
Python is used as the main backend development language for the project. This is because it provides a rich set of libraries and frameworks, making it ideal for integrating AI models and handling backend processes efficiently. FastAPI serves as a framework for exposing this Python functionality to the front end through API endpoints. FastAPI was chosen over other frameworks like Django or Flask as it is faster and supports asynchronous programming, which we needed for handling live audio processing and serving data to the front end in real time. It works with an ASGI Uvicorn server for high performance handling of requests. And the YouTube Embed API was used to integrate embedded video players directly into the application, allowing users to paste a YouTube link into the application and play the song. For automatic speech recognition, we use OpenAI's pre-trained Whisper model, specifically Tiny.en, an English-only model. We chose this model over other frontier ASR models like NVIDIA's Canary and Vosk because its format can be easily converted into OpenVINO's intermediate representation format. Additionally, the Tiny variant is lightweight and well suited for live processing, ensuring low latency inference. And for semantic text matching, we leverage Hugging Face All Mini LM, a transformer-based model optimized for efficient natural language processing. This allows us to compare the semantics of two texts and return an accuracy score. To further enhance the performance, we use OpenVINO, a toolkit used to optimize these AI models for faster inference on Intel hardware, making our pipeline both efficient and scalable. OpenVINO also ensures our models can be run on NPUs GPUs, as well as CPUs to meet the requirements of our Intel partners.
The front end of Reading Star is built using a modern and efficient tech stack. At the core is React Native to create a native Windows application. We then use TypeScript, a superset of JavaScript, to bring strong typing and better code maintainability to the project. NPM is used to manage all project dependencies and libraries efficiently, and this combination allows us to build a responsive, accessible, and high-performance interface tailored to the needs of neurodivergent children while ensuring scalability and easy collaboration during development.
Now we're going to sing a song with Reading Star, but first let's add our song to the playlist. As you can see on the right here, there is a list of playlists. I can add my song to these playlists. So let's create a playlist first. I type my name in and a new playlist comes up. It's asking me to add some songs. Let's go to YouTube and add a song. As a song is loaded, it will populate on the left hand side and join the playlist. And it will load here with the lyrics that I can sing along to with a progress bar along the bottom. Humpty Dumpty sat on a wall. Humpty Dumpty had a great fall. All the king's horses and all the king's men couldn't put Humpty together again. While the song is playing, I can also adjust the similarity threshold using the buttons at the bottom right to make it easier or harder, which effectively decides how strict it is in penalizing my pronunciation. We also have a settings option, which allows you to adjust font size, line spacing, the font style, the font color, the font's type, or the background when you enter focus mode. Now when you enter focus mode, the only thing that remains is the score, the video, and the lyrics. I can change the background using the aforementioned settings to concert or maybe even a stage. I can also switch on and off scoring at my will, so the user may not feel as pressured. Once done, I can delete the song from the playlist, and it will also give me a summary of my score and an accuracy.
Overall, we achieved our goal of successfully building Reading Star. We made an inclusive karaoke app for neurodiverse learners using real-time and offline AI. We integrated OpenVINO, which extracts every last bit of performance from Intel hardware, including NPUs. Furthermore, we received overwhelmingly positive feedback from test users, praising its accessibility and engaging learning experience.